Welcome to the course on basic genetics. As I stated in my earlier lecture, three of us, Dr. Richa Arya, Professor Madhu Gavaldas Tapadia and myself Jagat Kumar Roy, we will be taking this course, and we were from Department of Zoology, Banaras Hindu University, Varanasi. This is week 10 and this is the third lecture. The title is Other Banding Techniques. So, in my earlier talk, I did show you G-banded human karyotype. So, this is G-banded human karyotype, which is one of the best way of banding and karyotyping. But there are other banding techniques also available, and some of the banding techniques, they provide some of the important information also. So that is why we have to consider other banding techniques as well. One is Q banding technique. Q banding is quinacrine mustard banding. Quinacrine mustard is a fluorochrome, and this binds, this intercalates with 80 rich region of the DNA. So, here what you do, metaphase chromosome preparation is made on the slide as usual. Then these slides are stained with quinacrine mustard dihydrochloride stain. The concentration is 5 microgram per ml in water. Even 1 microgram per ml is sufficient for 10 minutes. As I said, the stain intercalates in 80 bases. Then rinse the slide thoroughly in distilled water and in sodium phosphate buffer 2-3 times each. Here washing is important because this is a fluorochrome. If fluorochrome is there on the slide, this will give you a background. So the total should be removed except where the intercalated fluorochrome remains. Then mounted in phosphate buffer and observed under a fluorescence microscope. When in the fluorescence microscope, the fluorescence quenches fast. There are different mountants which keep the quenching a bit slower, but otherwise the quenching is done in all the cases. So one should have quick observation and quick photography. That is important. So this is human quinacrine karyotype, quinacrine mustard karyotype using quinacrine staining. Here the brightly fluorescing regions are AT rich and these are also G-band positive. So wherever you were seeing G-band positive regions, these are the brightly fluorescing region here. That means they are AT rich region, they are heterochromatic region, and wherever you have light staining, these are the non-AT rich region, they are G-band negative regions. So this is equivalent to G-banding. Either you do G-banding or if you have fluorescence microscope, you can go for Q-banding, but still all the nomenclature, everything is with G-banding, so G-banding is a preferred one. So this is quinacrine mustard banding. Then there is reverse banding. This is another banding technique which you call it as reverse banding or R banding. Here again, the metaphase chromosome preparation is made on the slide as usual. The slides are heat denatured in saline sodium citrate. In banding, the saline sodium citrate or SSC have been very frequently used. So this is 2x SSC, means 2 times concentration of SSC. This is 0.3 molar sodium chloride plus 0.03 molar sodium citrate. So this is the salt solution and this is kept at 85 degrees centigrade. The slides in a coupling jar, the slide is dipped in that for 10 minutes. So this heat treatment denatures AT rich regions fast making them unable to take stain. That means the other regions which is non-AT, they may not get denatured that fast, and thus the chromosome morphology, everything remains okay there. Only in AT-rich region the chromosomes become less stained. So rinse the slides thoroughly in distilled water and stained in 5 to 10% Giemsa for 10 minutes. Mounted in phosphate buffer and observed under bright field microscope. So this is reverse banding. This, even without mounting, this will work, but always mounting is better. So mounting in a phosphate buffer and one can observe. This R banding, this is useful for studying the telomeres of chromosome, which otherwise are pale and hard to make out on G banded preparation. Because as when you saw the G banding, here the telomeric regions are very dull. Always the telomeres are very whitish. And here in R banding, the telomeric regions are more stronger. You can see here, this is G banded and this is the telomeric region here, this is more brighter. Telomeric region here is dull, here the telomeric region is bright. So this is a comparison of G banding and R banding. You can see the dark region, this is the dark region, this is lighter region, this is dark region. This is dark region, this is lighter region. This is dark region, this is lighter region. So this is exactly opposite of this. This is light, this is dark. This is dark, here this is light. This is light, here this is dark, like that. So this is reverse banding. Then another banding, today we will describe the another banding, and that is very important kind of banding. This is constitutive heterochromatin banding or C banding. Here metaphase chromosome preparation is made on slide. The slides are allowed to age for 2-3 days as usual. Then the slides are dipped in 0.1 normal HCl at room temperature for 15 minutes in a coupling jar. The explanation given was this cleans the chromosomes and makes it ready for the banding. Then the slides are treated with hot 80 degrees centigrade 5% barium hydroxide solution for 2 to 7 minutes. This is again to be standardized. That means you can have 5 different slides. One slide, this is done in coupling jar. So one slide you place for 2 minutes, another slide for 3 minutes, another for 4 minutes, another for 5 minutes, 6 minutes and 7 minutes, whichever gives you the better banding. This step, why are we doing barium hydroxide treatment? This step is to denature chromosomal DNA. So most of the DNA at this temperature is denatured in presence of heat treatment, in presence of the alkali treatment. So everything is denatured. Then rinsed vigorously in distilled water 2-3 times and incubated in 2x SSC solution. SSC is saline sodium citrate, as I discussed earlier. 2 times means 1x SSC is 0.15 molar sodium chloride and 0.015 molar sodium citrate. So 2x is 0.3 molar sodium chloride and 0.03 molar sodium citrate. So this is kept at, so after the slide is rinsed vigorously in distilled water, then you kept the slide at 65 degrees centigrade for 1 to 2 hours. This is called as renaturation. What will renature? The repetitive region, the repetitive DNA, that is, let us say AT-rich region, they will get renature fast because there are repeats, and thus they will have the chance to get the renaturation done. That means bonding, hydrogen bonding between the 2 bands easy, and thus this part will be able to stain better rest or most of the part that will not be able to stain, because that is remaining still denatured, and even with longer allowing renaturation, they may not be able to renature because they do not have repetitive region. So very difficult for them to find a region which is exactly complementary to them. So that is why they will remain denatured, and only the heterochromatin, only the AT-rich region, they will get renatured. Again rinsed in distilled water and then stained with 5% Giemsa for 15 to 30 minutes. Observe under bright field microscope. So here what we observe the central portion, mainly the heterochromatin region, quite dark. This is darkly stained heterochromatin region, that is what we observe. The other rest of the chromosome is not so dark. Then means this C banding, this is very important. One may ask the question that in G band, so many bands were there. That is why you are able to match and you are able to find its homologue correctly. You are able to recognize chromosome correctly. In this also, where you have mainly the heterochromatin region darkly stained and the top that is the telomeric region darkly stained, rest of the region very lightly stained. So how this will, with this you will be able to pair with the other, its homologue, or you will be able to identify. If you do it, you will be able to see with the kind of heterochromatin staining the exact match, and that is how this is also a very good technique for pairing the chromosome, for identifying the chromosome. And most importantly, I did describe the technique that here you kept the slide initially with HCl for a short brief period, then you treated with alkali for denaturation, then you allowed SSC renaturation for longer period at higher temperature at 65 degrees centigrade. Exactly from this technique only southern blot technique has come. There also the DNA is run on a gel, DNA may be digested and then it is run on the gel. After running the gel is treated with HCl for a brief period of time. There, this is helpful because the acid treatment removes some of the bases, some of the purines, and thus make the DNA very easy for the transfer. So in case of exactly the reason why the slides were treated with HCl may not be clear, but there the explanation given was better cleaning, and here in the exactly the same technique in southern blot, this is for a purpose for depurination. Then here in the southern blot also the denaturation is done, this is alkali denaturation that is done, and followed by the probe hybridization in SSC at 65 to 70 degrees centigrade, that is 10 degree less than the temperature maximum or Tm. So this helps in the hybridization of those regions or of those things which are repetitive and which can easily hybridize. The rest portion is not having very convenient condition to get hybridized. That is why the temperature 65 is kept. So the same technique, the C banding technique, which is an important banding technique, now you have the southern blot. This is also a very, very important technique for DNA. So this is some of the activity and discussion. You should make a comparison of G-banded, Q-banded, R-banded and C-banded human metaphase plate. Compare the mechanism of each of the banding types studied, and are these bands remain constant? I did say that they remain constant. So, these are some of the discussion points for you. Thank you.